Hello everyone. Today we'll be discussing composite functions from the chapter Algebra, unit Functions in our IGCSE syllabus. And what we'll be doing is working with practical examples. We'll start out with a simple function, a variable x. Let's say then f of x is equal to 2x minus 3. Where x can take any real value. Now what we know about this function is that its variable is named x. So the numerical value of the function depends on the numerical value given to x. For instance, if x was equal to 1, then we would get f of 1, which we obtain by replacing the value for x with 1. So 2 times 1 minus 3 is equal to 2 minus 3, which is equal to minus 1. Pretty straightforward now. Then a second function, which we will call g of x, is equal to, let's say, 2 to the power of x. So that we have a different type of function. And let's give x the value 0, which means that we get g of 0 is equal to 2 to the power of 0, which is 1. So now then, we have two examples of functions, f and g. So then, what are composite functions? Well, we can start out by saying the composite function f of g of x. Now what this means is that in our function, which is f, we replace the variable x with the variable g of x, thus obtaining a composite function. Let's see what that would look like. So we know that f of x is 2x minus 3. So if we replace x with g of x, then we would have 2 times. No longer do we have x, we have g of x minus 3. We need to look now and see who the function g of x is, and it's 2 to the power of x. So then we have 2 times 2 to the power of x minus 3. This is our composite function. If we use indices, then we have 2 to the power of 1 times 2 to the power of x, which means that we would get 2 to the power of x plus 1 minus 3. So there we have it then, the composite of f and g. F g of x is equal to 2 to the power of x plus 1 minus 3. Let's say we want a specific value. We want f g of 2. That would be then again obtained by replacing x with 2. So it's 2 to the power of 2 plus 1 minus 3. 2 to the power of 3 minus 3, 8 minus 3, giving us 5. What if we did not have f of g of x, but we had the composite g of f of x? Would we have obtained the same thing? Well, g of f of x means g, and we replace the variable x with the function f of x. Thus we would get, in the function g of x, which is 2 to the power of x, we don't have 2 to the power of x, we have 2 to the power of f of x. X has been replaced with f of x. So that means 2 to the power of 2x minus 3. Therefore, we can say that our composite function g of f of x is equal to 2 to the power of 2x minus 3, which is not exactly the same as 2 to the power of x plus 1 minus 3. Should we try for a numerical value here also? Let's say we want to try again when the value for x is 2. So g of f of 2 would then be 2 to the power of 2 times 2 minus 3, which is equal to 2 to the power of 4 minus 3, 2 to the power of 1, which is equal to 2. To sum it up then, we know that f g of x is f of g of x. So we obtain the composite function by replacing the variable x with the function g of x. Let's try another example with two other functions. F of x shall be, let's say, minus x plus 2. G of x shall be x squared plus 1. Okay. We will start with the composite fg of x. Fg of x will therefore be the function f where we replace the variable x with x squared plus 1. So then it will be minus, because we have minus before the variable x. Let's put this in brackets. X squared plus 1 plus 2. What we see again, x squared plus 1 takes the place of x from f of x. We eliminate the brackets, thus having minus x squared, minus before plus 1, which means minus 1, plus 2, is equal to minus x squared plus 1, because minus 1 plus 2 is plus 1. So this is f of g of x. Now, our other composite, g f of x, we obtain by replacing the variable x in the function g with minus x plus 2, which is our f of x. So then, we have something to the power of 2, but no longer the x. We have minus x plus 2 to the power of 2 plus 1. We can work this out using our formula for a plus b squared. Let's remind ourselves our formula in the process. It's a squared plus 2ab plus b squared. So then using this formula, minus x plus 2 will be minus x squared, which is x squared, because minus to the power of 2 gives us plus. Okay. Plus 2 times minus x, so then we will have minus 2x times 2 plus 4 plus 1. It will be therefore equal to x squared minus 4x plus 1 plus 4, so then plus 5. This is gf of x and fg of x minus x squared plus 1. And that's how we obtain composite functions. So there we have it then. Two worked examples for composite functions. Thank you very much for watching and enjoy doing mathematics further on. Have a good day.